All right, welcome to the last section of Chapter 1. Today we are in 1-4 Distributive Property. So our goal today is to use the distributive property to simplify expressions. All right, so as I said, we are going to be working on the distributive property to help us simplify. Reminder, simplifying mean we're going to make our equations easier. All right, so quick reminder, I think you guys have heard distributive property before. Remember, to distribute, it means to make or solve problems in a simpler form. It means we're going to take that number in front and we're going to multiply it and we're going to make the equation look nicer, easier, simpler. Okay. We're going to see this word coefficient. You're going to see this a lot this year and you're going to see it throughout your high school math life. Coefficient, it's the number in front of the letter. Remember, letter is variable in math. So for example, that 5v, this 5 here, we call that the coefficient. It's the number in front. Okay. Like terms, I know we've probably talked about this already. Like terms, these are letters or variables that have the same variables. So A's go with A's, B goes with B's. A's and B's, they're different letters. They don't go together. Okay. So we're going to be seeing these three words throughout this lesson and also throughout the school year. Reminder, if I'm going too fast, to pause the video as you need it. All right, so when we're talking about distributive property, you guys have probably seen this before. So when you have a number or letter out in front, what you're going to do is you're going to take that and you're going to multiply it to everything that's inside there. So I'm going to take this A, for example, and I'm going to multiply it to the B and to the C. So when I do that, I'm going to have AB plus AC. If you had numbers, for example, I'm going to take this 4 and I'm going to multiply it to the 20 and I'm going to multiply it to the 6. So what we really have is 4 times 20, which will give us 80, plus 4 times 6, which gives us 24. And then we would add those and get 104. So as you can see here, we use distributive property to help us make problems look easier or to help us solve it. So for example, getting 104. All right, so here we go. Let's try this. I would really recommend, as you can see on those first two problems, I did kind of draw little arrows to help me know what I'm multiplying. I think it's a really good idea just so you kind of know and see what's going on. So for example, I'm going to take this 3 and I'm going to multiply it to the x and I'm going to multiply it to the 8. When I do that, when I multiply 3 times x, I'm going to get 3x. When I multiply that 3 to the 8, 3 times 8 is going to give me 24. All right, so this is kind of where I was talking about at the beginning. 3x and 24 are not like terms. The 24 doesn't have an x, so I can't combine them. So this is my answer. I am done. I can't take that further. I can't solve it. I can't combine it. It's done. All right, number 2 looks a little weird here. The number that we multiply, it's in the back. If you need to rewrite it with a -7 in front, you certainly can, but it is the exact same thing. So again, I'm just going to take this -7 and I'm going to multiply it. This time when I take -7 times this 5b, I need to multiply that coefficient, that front number, the 5, to the -7. So when I do that, I'm going to have -35, and our b is taken along with those guys. So I have -35b. I'm also going to multiply to this -4. Watch your negatives. As we have already talked about this week, a negative times a negative is going to give me a positive. So I have positive 28. Again, the 28 does not have a b on it. I can't combine them. So again, this is just my answer. For a lot of you, this is probably a review. So distributive property should be a nice review lesson. All right, we are flipping pages. If you would take a moment, grab your calculator, pause, try out these 4 problems, and then once you're done, push play, and we'll talk about them. All right, welcome back. I assume you paused, and now you're pushing play. This one, I'm going to take this 5, I'm going to multiply it to everything. So I have 5 times x, which is going to give me 5x. I'm going to multiply it to that 7, so I'm going to get 35. These are not like terms, so this is my answer. Now this one, some of us might think like, well, there's no number in front, so there's nothing to multiply. But we really do have a number in front. There's really always a 1 out in front. So now what I have is -1. So I need to multiply everything by -1. Since we're multiplying by -1 to everything, all of our signs are going to switch. They're going to be the opposite. So when I take -1 times +4x, I'm now going to have -4x. When I take -1 and multiply by -12, I'm now going to have +12. Sorry, that no like terms, so we are done. That's why I squared that one up right away. Sorry. All right, this next one, I'm going to multiply this 3. Now, we do have decimals. It is fine, though. You can just grab your calculator. We have 3 times 0.4, which is going to give us 1.2. I'm going to take 3 times that 1.1, and I'm going to get 3.3c. Again, I can't combine these, so this is our answer. If you want to get really crazy and write it in proper math terms, you could put that 3.3c first. I won't require that, but that is a good answer as well. All right, and again, this last one, I'm going to take this -6. I'm going to distribute to everything. I'm going to have +18 plus 12x. Again, I can't combine those, and if you did flip it to be proper math writing, that is great as well. All right, so that is the distributive property. I'm going to assume for a lot of us, excuse me, sorry, that should be a review. All right, now let's talk about like terms. Now again, this is probably going to be very familiar. Reminder, like terms is referring to variables that are the same and therefore you can add or subtract them. All right, so if I'm looking at this first one, I'm just kind of asking you, are these like terms, yes or no? So on this very first one, I have a 7a and a -3a. Since they both have a's, yes, these are like terms. Okay, if I'll underline those a's for those of us who need to see that visually. On this next one, I have x squared and x squared. They are both x squareds, so yes, they are like terms. Now I want to talk real briefly. If I had an x and an x squared, we would say no, those are not like terms. Now I know they both have x's, but one has a squared and one doesn't, so those would not be like terms. This next one, I have an AB and an A. Now again, they both have A's, but they both don't have B's. So because they don't have the exact same thing, this is going to be a no. These are not like terms. And finally, on this last one, again, I have x and y's, but notice the one on the right here. The y is squared, whereas on the other one, the x is squared. So they're not quite like terms. They almost are, but because they're not perfect like terms, they are not like terms. Okay. All right, so let's try this out. So what we're going to do is we're going to combine like terms. So we want to make these problems simplified. Okay. So number 7, I notice I have an 8x squared and a 2x squared. So because they both have x squareds, yes, I can combine them. Now I need everyone to notice, I'm just going to bring down the x squared. You do not do anything with the squared. Don't mess with it. It's just saying, hey, I have 8 little x squareds, I have 2 little x squareds, and I want to combine them. So if I take 8 plus 2, that means all together I have 10 little x squareds. Again, that x is being squared, you don't do anything with that squared, okay? This next one, if you're a visual person like me, we want to get like terms together. So I'm going to kind of put those together. I have these x's, which are like terms. Notice the sign in front is going with that x. I have this y here, and we have just regular numbers, okay? Oh. I don't know why my green marker is not working. Okay, there we go. Woo! All right. Okay, so I have 5x minus 3x, so that means I have 2 x's altogether. I have no other y's besides that 6y, so I'm just going to bring that down. I'm going to say plus 6y. I also have -3 plus 4. This should be a review. We've been talking about positive and negatives and adding them. So I'm going to take -3 plus 4. That is going to give me +1. I look here, is there anything else I can combine or simplify? I can't combine x's and y's. I really like this order. I really like this alphabetical order. So this one is done. There's nothing else we can do there. Okay. All right, take a moment. You try, pause the video, push play, try it out. Okay, so in this next one, I see that they both have mn to the fourth, mn to the fourth. Now, as I said, you do not worry about the exponents. I'm just going to bring that down. I have mn to the fourth. I have -7 of them, -5 of them. So when I combine those all together, I'm going to have -12 mn to the fourth. Okay. This next one, we really need to notice where the power is. So I have this y to the third times z. So I notice I have this one and I have the exact one here. Now notice this one doesn't really have a coefficient in front. So if there's ever not a number in front, you're going to just put a 1. There's really a 1 there. Now that yz to the third, it looks almost the same, but it's not the same. So that can't go with those two. So if I have 7y to the third times z and 1y to the third times z, we can combine those, and all together I'm going to have 8y to the third times z. Because that other one doesn't have anything else to combine with, we're just going to bring that down. So I have -6y z to the third. And that is our final answer. Okay. Again, if I went too quickly, make sure you're pausing and going and rewinding. All right, I have one last question. It's kind of a challenge question. So if I'm looking here at this problem, it says, can you simplify 8x squared minus 2x to the fourth minus 2x plus 2 plus y plus xy further? Explain. So right now, if I'm looking at this, do I have any like terms? I do not. There's nothing that can combine. So can we take this further? The answer is no, I can't take this further. The reason why, none of the terms are, oh, what happened? None of the terms are like, I don't know what's happening right now, are like terms. Okay, so none of them are the same. So we cannot combine them. So that what that says right now, I don't know what's happening with my board. So the answer is no, none of the terms are like terms. All right, thank you, and I will see you in class.